Today's video will define the test-driven development process. Hello, I'm James Helfrich. Gone are the days when we first write code, and then at some point in the future, the code may be tested, and then we fix the bugs. The new process we develop software is quite different. First, we write the test. We ensure the test fails. Then we write the code just enough to make the test pass. Then we pass the test, and then we refactor the code. This is called the test-driven development process, and this video will define that process. The conventional software lifecycle model goes from requirement solicitation to design to develop and to test in one big go. This is true whether the lifecycle is measured in years in the traditional waterfall model or for 1 week sprint in Scrum. And so you start and then you gather requirements and you get all the requirements necessary for the entire project. Then you design for the entire project. Then you write all the code for the entire project, and then you start testing it. And if it works, you're done. If it doesn't work, if it's a little broken, go back and fix the code. If it's really broken, then go back and design again. And if it's really, really broken, then you're supposed to go back and get the requirements again. Now, the problem we have here is there is a long span between when you find the bug in test and when the bug is introduced, either at the requirements stage or the design stage or the coding stage. And the longer that time period is, the more inefficient it is to fix that bug. Now, with test-driven development, this is a reordering of the activities. First, we create the test, and then we write the code to make the test pass. So first, we're going to start, and then we're going to get one requirement, and we're going to write the test before we write the code, and we expect that code to fail. And then we're going to write the code for that specific test and that test only. And then we're going to see if the test pass. If it does not pass, then we're going to rewrite the code. If it does pass, is there more to be done? If the answer is no, we're done. If the answer is yes, we're going to get a single requirement. Now, notice this whole loop here from getting one requirement to the test pass is measured in minutes, preferably 5 minutes, maybe 7, but super, super small. And the idea is that when the test fails, we know the 1 or 2 or 3 lines of code which caused it. We don't have to debug with hundreds or thousands or millions of lines of code to find it. And so we're going to have a very short time between the bug introduced and the bug is fixed. And that is the essence of test-driven development. So let's take a look at the test-driven development promise. Number one, we're going to eliminate poor test coverage because we don't write a single line of code unless there is a test that requires that line of code. We can get 100% code coverage. Second, we're going to eliminate over-engineering. We only write code if we're required to for a test. Therefore, every line of code is going to map to exactly one requirement, and we're good to go. We're going to minimize lag between when the bug is introduced and when the bug is fixed. And we discussed that earlier. This lag should be measured in minutes, not hours or days or months or years. We're going to have a tight development cycle. The development cycle is very short, once again measured in minutes, not in months. And so from the time that we have the requirement until it is implemented is going to be 5, 6, maybe 7 minutes. And lastly, we have better design. Because we have to write a unit test first, before we write the code, we tend to write code that is unit testable. And when code is unit testable, then it tends to be very configurable, have high degree of abstraction, very transparent, and all the other things we really want. Hacking code together is just too difficult to support. So let's take a look at the high-level process. First, we're going to start, and then we're going to gather a requirement. Now, from this requirement list, we're going to then create a test for just one specific requirement, and this will be a unit test. And then we're going to run the test, and this test better fail. Why should it fail? Because the code has not been written yet. Now, sometimes the test doesn't fail, which means it's not hooked up correctly, or the test is malfunctioned, or maybe we're lucky and the code is actually implemented. But at any rate, we are expecting the test to fail. Then we're going to write the code to make that test pass, the minimal amount of code necessary to make that test pass. And then we're going to refactor the code according to our software metrics for efficiency, for maintainability, for abstraction, for cohesion, for coupling, whatever metric is relevant for this particular set of code. And then we're going to cycle back and we're going to do it all again. You can learn more about the test-driven development process in the test-driven development promise in the test-driven chapter of the software design textbook.